Welcome to ENME351 Lab 3. Let's go. Reviewing our code for exercise 1, we have a serial begin at the correct baud rate. We read in our end scope through A0, read in our frequency through A1. We send our end scope value to the serial port, and we adjust our frequency to be around 500 Hertz based on the maximum position of the potentiometer, and then we delay by a delta t related to that frequency. And there we go, just as we want it. So we finished our exercise 1 measurements. Here's our data for the 100 Hertz sampling values. They all demonstrate aliasing. Here's our data from the 142 Hertz sampling. They all demonstrate aliasing as well as we expected. Here's our data from the 200 Hertz sampling rates. The top two, which were taken with a sample of 75 Hertz and 100 Hertz, do not demonstrate aliasing, while the bottom two do, as we expected. And here is our data collected from samples at 500 Hertz sampling rate. The top two do not show aliasing. The bottom right one from a 300 Hertz does show aliasing, and the one collected at 215 Hertz shows a little bit of aliasing because we weren't able to get our sampling rate to exactly 500 Hertz. It was more around 412. That's because the sampling rate was very hard to fix because of our sensitivity to our potentiometer. Here's the table for exercise 1. Those circled in blue did not exhibit any aliasing at all. Those in red exhibited a little bit of aliasing but shouldn't have, just because of our sensitivity to our potentiometer, and the rest demonstrated aliasing as they should. Experimental aliasing frequencies were taken by looking at the VSA measurements. Theoretical values were found by plugging in F over Fn and looking at the folding diagram. Those charts and tables were a lot to take in, so I'm going to upload a copy of those when I submit my YouTube video. Exercise 2 here, we got a square wave running using our pulse from the end scope. And as you can see, we're getting a square wave on the VSA. You can see this amplitude spectrum plot is basically creating a Fourier series for the square wave. Looking more at our amplitude spectrum plot, we can see that this 10 Hertz spike corresponds to about N1, about 30 Hertz, N2, 50 Hertz, N3, and so on and so forth. You can see these little spikes that would represent the terms in the Fourier series. And now our triangular wave provided by the end scope. And here on our VSA, you can see it's showing a triangular wave as well. This amplitude spectrum plot is much simpler. You can see our DC offset of 2.5 volts at a frequency of 0. Then about 10 Hertz, which is what we expect, you see another spike. That would be the main term in the Fourier series. There is a little bit of spike around 30, around 50, around 70, and then some smaller spikes. And those would be the other terms in the Fourier series to get our original sinusoid from the 10 Hertz spike to look like a triangular sinusoid with the rest of the spikes. So those are the rest of the terms in our Fourier series. All right, guys, that was Lab 4. Thanks for watching.